Welcome to the Data Masterclass Podcast, where data leaders share their unique stories. In this episode today, we talked with Simba Khadder, who is building the context engine for agents at Redis. On the topic, all you need is context. Why AI apps in 2026 will be won by data, not just models. Let's welcome your host, Alexander Borek.
Hello, my data friends. We have a very, very special guest today with us who's been doing major contributions to the open source community and to the community around the world. We have Simba Khadder with us, who's the head of AI products at Redis. And before that, he has actually been building his own company, which was acquired by Redis, which is called Featureform. And we're gonna dive in to why what he has been building and is building as part of the context layer is a centerpiece of any modern stack for agentic podcast, Data Masterclass Podcast.
Thanks for having me. I'm excited.
Let's dive into your story directly. Why did you start doing these things?
Yeah, it's a good question. I started my career at Google. I was actually a software engineer. Very quickly realized that I loved to build. Throughout college, for everything, I always was like building. I liked to build. I was doing hackathons. I was just always, that was the thing that drove me. And that's the thing where I learned the most. I think I optimized my whole career on where can I learn the most, the fastest. And I think every time I felt like I wasn't learning enough, that's where I started to get the itch to like expand, do more, take bigger swings. And so that resulted in me starting my first company. And then I actually built Featureform there. The first company was doing personalization at scale. We had like 100 million monthly active users. We were doing recommendations, predicting subscriptions, predicting churn, as for our users or our customers' users. So, and this is pre-LLM. So it turned out that features drove everything, and so we built a feature store, and that kind of spun into and became Featureform, which grew and as LLM Wave came in, we expanded it. We added more products around LLM stack, and Redis saw what we were up to. Redis had always been an amazing partner of Featureform, so it was a really natural home for Featureform, and it's been really cool. Both products remain. We have a lot of new products now. The team all came on, so it's really been. I've been very fortunate, and very maybe very lucky too.
Now, when you start a company, I compare it to starting a PhD. Like you better choose the right thing, because you're kind of getting into like a small marriage there, for a while. So what made you choose this problem? Like why did you find this problem so fascinating and worth solving?
Yeah, I think what's interesting is when you start a company, everyone thinks, oh, they need this like big idea. And I actually am of the belief that whatever idea you think is right is wrong. Like whatever you think you're building is actually not what the market needs. It's like the quote, everyone has a plan until they get punched in the face. That's the same idea. Like you have this great plan, you build this thing, you release it, and you find out that, it's not exactly right. And so a lot of starting a company is actually just the desire to work on maybe a space. In my case, I really just found data engineering, ML, just to be fascinating, especially around recommender systems. And I like working with people in that space. I just personally found that space to be super fascinating. And so that's what drove me to do it. Even the way I built, like we were open core in Featureform. That was the kind of company I wanted to build. And a lot of the work is actually just kind of figuring out what is the right shape of the solution. And it's a little bit of creativity and a little bit of just like working with a lot of people and figuring out what's needed. But in a way, it's like whatever you think it is that you're building, whatever you think it is that you're doing is not what you're going to end up doing if you fast forward. I mean, like a good example, the funniest example of this is like Slack started as like a video game, you know, and if you told them back then, oh, by the way, you're going to be this massive company and everyone's going to use you for like, you know, in office communications, like it's an email killer, I don't think they would believe you.
Yeah, it's such a great story. It reminds me also of Nokia, you know, where Alexis used to work in his early career, you know, which came from kind of tires to, I think, from rubber kind of production. And, so that's amazing. And so you kind of discovered, and so what I would be fascinated to hear is like when you started this, what problems did you think you're solving, and which problem did you end up solving?
Yeah, I think so the first Featureform was actually born out of a company before it. That company was doing more personalization, recommender systems, worked with a lot of media companies. And when we were building these models, we were doing a 2-tower recommender system. At that point, the YouTube paper had just come out, so it was like very new, cutting edge stuff. And I remember actually back then, a little small tangent was when I first really got my hands on embeddings, like user embeddings and item embeddings, I remember thinking, man, this is magical. And I would kind of nerd out to people about, you know, how much you can do with these things, and no one cared. And then you know, like many years later, RAG became a thing and LLMs became a thing, and it became more common knowledge. But well, with that company, what I found was even though we were implementing, we were reading all the papers, we were doing, I used to say Andrew Ng, you know, the famous Coursera course, I used to say, you know, he lied to me. He told me that it was all about the model and everything I did was the model. I'm going to have this nice, beautiful CSV to train over. And I never saw that nice, beautiful CSV.
Never. Yes.
And I'm still waiting. Maybe it's somewhere.
I started my career as a data scientist at IBM, you know, and we were crunching seller data and country data from all the countries around the world, you know, 80,000 sellers in the system. And the data was, well, like basically, you know, until you came to the point where you could do any model, you had to spend like weeks, months to just clean data. I mean, we all know the story, but it's just for me, it's a personal story because, you know, that was my first real life job after the PhD.
And for us, the thing that also made it really complicated was we were dealing with massive scale of data and we're dealing with streaming, real-time data. Right. And, you know, like I used to joke, it's like I have this, you know, my data scientist would be like, oh, I have the model, it works. It's in my notebook. I'm like, great. That's not useful. Like, how are we going to get this thing in production? And that was the hard part. And almost always the hardest part of it wasn't actually the model part. That was a little more figured out. It was the data. It was just such a pain. And so we built, what I wanted was Terraform, which I was a big fan of, for features, for like feature pipelines. And so I built Featureform.
Yeah.
And so that was kind of the genesis of Featureform. It was really to solve the data problem, especially real-time data for machine learning. And I think we've, you know, when we started, it looked very different. It looked, as we've kind of evolved, we've really like built around what data lakes look like. We've built around Iceberg. We're like Iceberg native. Like there's a lot of things that we just could never have predicted. Some of those things didn't even exist when the company started. And so eventually we really fell into something that, you know, drove tons of value to our customers. And in fact, we post-acquisition, we released Redis Featureform, which is kind of like a major version upgrade of Featureform, but the first one that was kind of Redis built under the Redis umbrella. And so Redis is actually really investing heavily in the space, which even though we spend a lot of time talking about LM, and I'm sure we'll spend a lot of time today talking about that, it's actually most well, AI...
we love context layers. In this call, we love context layers, by the way. So you came to the right place.
Yeah, exactly. But it's funny with like, we talk about AI, and everyone thinks LLMs, everyone thinks all the agents, which there's a ton of value creation. I think actually much more value creation will come out of it. But today, if you were to take a screenshot of like what quote unquote AI is in production, it's mostly fraud and recommender systems running on like good old fashioned ML models. And so, and that won't change. There will be much more, but I don't see in the short term that those types of models are going to completely switch over to LLM. It just doesn't match the model type and problem space.
And so basically, I mean, the way I understood it, the problem that you solved was kind of creating like a DBT core on the analytics side, something similar for feature stores. Because I mean, I know that from practice. Like at Zalando, we had lots of ML people, and all around the company. And usually, a few things happen. One is everyone rebuilt the same features over and over again. So we had duplications over duplications. The second thing is you trained on different data than on the data that you actually deployed. And when you go into near real time, correct? That's kind of another big issue. So, maybe it comes all from the same Kafka stream and it ends up in your lakehouse, but somehow it is different.
It ends up different, and I see a lot of teams build separate pipelines. They have their like streaming pipeline and their batch pipeline, which they use for training. And then it's very easy for those things to have, kind of nuanced differences. Sometimes not nuanced, but someone misses it. Having even just proper versioning, proper lineage, just unifying these things. I mean, what we want and the thing that we strive for is make it as easy as I have this idea, I can write it for you in SQL or Python or rather in data frame code, and then you handle the rest. Here's the logic. I want you to make this and operationalize this for real-time serving and for training. That's kind of the promise of Featureform.
Mm. And so in practice, like I mean, one of the things that I found always hard about it, that it's not only a technical problem, because it's a behavior change problem. How would you look at that,
Totally. I think the big thing there, especially on the ML side, is there are a lot of teams that work together, and I think sometimes it creates kind of dysfunctional. It's almost like the organization tries to figure out how to solve this problem. And what I see a lot of teams essentially building a waterfall. Like I have my notebook, I give it to this team does this, then they give it to this team, and they pass it back. And the data eng team actually productionizes these things, and then the data eng team has to go talk to another team to actually go. Sorry, it's going to be a plane that's going to go by.
Funny side note, both Simba and I are on different airports at the moment.
Yeah. But yeah, so I actually think that a lot of problems are actually organizational problems, and the org will do whatever it can to try to solve the problem at hand. But sometimes I've always taken the approach when building teams of trying to give as much ownership as possible to the people who care the most about it. The people who care the most about getting this model in production is probably the ML people who actually built the model. And so the more I can kind of empower them to be able to kind of think and iterate and build, the better off the organization will be. And then to an extent, you can also hold, like, you can let them do and everything that they want to do. And then there's also, like, to an extent, like, there's less friction. You get less people, like, kind of giving up and just, whatever, this is just our process. It takes 3 months to get models in production. So I think a lot of things is actually limiting communication in a way, or not forcing communication to get things done, where you're kind of self enabled. You can do what you need to do, and you talk to people to learn and get more information and to share ideas, and not every single time you need to get work done.
So one thing that we firmly believe in as a principle of organization that works is kind of the mesh principle. It's known through the data mesh. We also expanded it to analytics and agentic mesh in our work. And kind of the idea is that you have self-organized teams that have a lot of sovereignty, but at the same time, in the domains, you kind of come together and like in a traditional village, where people come together to the market square and discuss how to organize that village, and so I think that could be also a way, how this works out. So I'm curious actually, how would you envision your product being used if you have several ML teams, inside a company, which is now often the case, how would they collaborate on it, to create, let's say, synergies without bottlenecks or without, restrictions.
Yeah, I think the big thing is the way Featureform works is we build these concepts called workspaces. We have basic access control rules around those workspaces. So typically, what we see is teams will be in different workspaces. You can set up your data. You can register. I have Databricks. I have Snowflake. I have whatever. Here's what my raw data is. Here's the workspaces are allowed to touch these things. And you can end up in a really nice place where, again, like every team can really focus on what they need to do. And every team can also, if you let them, see what other teams are up to, if you want to take features from other places. The other nice thing is, because it's declarative, one of the worst things, super common things that happens is, I joke, it's a little bit, dramatized, but it's like untitled 128.ipy notebook in production, And a lot of what Featureform also does, this is what Terraform does too, is it makes it so that there is a clear, defined path to define features, productionize them, etc. And I think that's something that that really makes it easier to iterate, to learn, to work, because it's all in one place. It's just all definitions, declarative. I think making things declarative just works really well for ML models and data specifically.
And so if everyone works in their own workspace, we know that from that's the typical setup these days. Then the question is, do you also set up a common space where people share things?
So typically where we see that is more on the Git side, so the code gets shared. It depends on who can see which data. So, but oftentimes it's on the code side and allowing people. In fact, one thing we've done at Redis, which I really love, internally, is we say every repo internally, obviously barring security, whatever, things that can act like open source repos, we try to make them act like open source repos. Talking about enablement, like it enables any team to be able to really see what other teams are up to. They can contribute. It's not that they just merge in anything that someone creates. Like there's contributing guidelines. It works exactly very similarly, rather, as an open source repo would, because open source has figured out how to make large teams and teams that some people are maintainers. They're always on the project. Some people are just coming by to do something. So we've really learned from that and taken it there, and I actually think that applies really well to many domains.
Okay, but basically, if you want to share kind of your configuration, basically what you do is configurations. Yeah, it's like to my understanding, to what I understood, is basically a virtual feature store which you kind of declare with declarative language, and then it goes into an engine like Databricks or other. Like, what are the typical stacks where it's executed actually?
The most common are almost always going to be Databricks or Snowflake for the transformation piece. We always write to Iceberg. We do support Delta and other things, but we like Iceberg. And then for online serving, Redis as the online store. And specifically, we see a lot of Redis with Flex. Flex is, so a lot of people think of Redis like in memory and non-durable. With Flex, what we do is we actually push least recently used values to SSD. And so what that enables is like you can have a terabyte or more or many, and we actually have huge online stores, like 100 terabytes plus on Redis, and we're able to do that because we can push to SSD when needed.
And so what's typical architecture here? You already mentioned Redis, and so Redis basically feeds the data usually from something like Kafka, or like what's the usual, or is it a direct copy of?
Yeah, the way to think of it on the ML side is you have your data that comes through, let's say it's coming in through Kafka, or you have your data lake or whatever, or usually it's a mix. Um, what you need to do, getting to like the perfect CSV point, like you need to build and define transformations to build proper data sets that have your features and your labels. You can annotate, hey, these are features, these are labels. This is a training set. A training set's built up of this label, these features, or whatever. Eventually, the artifacts that you need two. One artifact that you need is for training, which is going to have historical values. So have labels and it'll have historical values of features. Like if I had,
And that's the model lakehouse environment, I guess. Or do you do that
Yes.
also on top of it? Yeah.
That would be, it would be, it shows up as an iceberg table, even though
Yes.
the abstractions kind of hide it, but under the hood it's an iceberg table. And it shows up in Unity or Glue or whatever catalog you use. In fact, a lot of what we do with Featureform is really push for like open standards. It's almost like let the data scientist or ML person work in Featureform, which speaks their language, but make it translate to something that a data engineer would be very happy with. We see a lot of situations where the feature store and the data lake are just completely separate.
Yeah. I've seen that so many times.
Yeah,
It's rather usual, rather the norm now than the exception right now.
Exactly.
Yeah.
And so so what you end up with is the training artifact, which is an iceberg table. And then for serving, you need, like, for example, if you're doing recommendations or fraud, you're going to need low latency serving of pre-computed features. And so Redis becomes almost, it's an online store is like the term feature store people use, but I think I like the term, it's a materialized view of features.
Yeah, so basically it's the materialized view, correct? It's basically the store in it, while what you have is basically the declarations of things.
Correct. So we almost act
and this way it can be served very, very fast.
Yes, because you don't, if you're, let's say, a music app with recommendations, you can't wait, you can't go run a query for 30 seconds, or even if it's fast, like you can't pay the cost of doing that every single time someone opens the app. It doesn't make sense.
So
what's interesting is that, so we recently released Redis Iris, which is kind of our context engine thing. And if you look at it and you kind of squint a little, you start to realize that it doesn't look that different. The architecture doesn't look that different from a feature store. Now, there are some things that are inherently different. There's no such thing as training. But what's interesting is I used to say in ML, there's only two hard problems. There's data, and then there is evaluation. And in agents and LLM, there are two hard problems. There's data and there's evaluation.
It doesn't get easier. Evaluations don't get easier right now with agents.
And the reason why that these things always remain so hard is because it's always going to be so context dependent. It's going to depend on your business. It's going to depend on your company. There's no way to generalize it. You can give tools, like with Iris, we give a tool that makes it, gives you what you need to build the right solution.
To start organizing your internal stuff, basically.
Exactly. But there's no magic wand where you just kind of like as opposed to let's say inference, where you can go use a model provider like a base 10 or something, you're kind of, in a way, obviously there's a lot more to it.
Yeah.
But
I mean, it's like the LLM model. It comes out of the box, which is very different to context.
Exactly. The context is going to be super dependent.
Unless your context is the internet, then you're fine, or something, public or something outside of your company. But most companies need their own context.
Exactly. And so I think right now that is the most critical problem for companies to solve. I think the hardest problem and the most important problem for companies to solve right now is the context problem.
What have you found out about that problem so far?
Yeah, a ton. And maybe going a little bit back, LLMs, the architecture everyone did was RAG, and RAG is even though we like to complicate it, in essence, what it is a user asks something, you do a search, on top of your data, grab some relevant paragraphs, pass it to the LLM with the user question. So that is RAG.
It's kind of search and filter kind of, yeah. Like you have a data, like you have a database of unstructured stuff, you search it and you filter it.
And what you end up with, like what most RAG systems...
And rank it somehow, to filter it.
Yeah, there's a lot more you can do to make it. But at its in its essence, that's really what it is. And what you end up with is essentially a glorified summarizer.
Yeah.
That's most of what you get. The most common, obvious way to show this is if you build like a customer support agent and someone asks, let's say it's food delivery, and someone asks, why is my order late? It's going to say, here are common reasons for delays, because it's going to find some knowledge-based thing about here are reasons people are late. But I don't care about that. I want to know, why when my order is going to get here and why my order is late. And so that's kind of the fundamental problem we ran into with RAG is RAG just allowed us to take the power of an LLM, which at the time was so new and just even talking to LLM without RAG was already pretty magical. If you added, some kind of RAG and snippets of your context,
it would have some local knowledge of your stuff, basically.
Now, what's changed is back then, if we use coding as a kind of way to see how far LLMs have come. Back when RAG was kind of early and really the core architecture, most coding tools were essentially tab complete. Now, everything's you put in, hey, I need to build this feature, and it can go and build it. In fact, the Anthropic has this number which I love, which is that the amount of times an agent can work independently on a software task specifically is doubling every 6 months. So
I just said that Andrei Karparov just said, basically in a podcast, he said, I actually stopped looking at the code. And he said, it found in one of my kind of big, my libraries that I'm a repository, my repository that I've been most proud of, it found a deep bug.
Yeah, it's humbling. Especially the bug catcher ones, like it finds stuff that people miss. Obviously, it's not perfect, and it's like there's a way to do it, but it is humbling when you use these tools for a while.
How do you feel about it? I mean, your identity, I guess, is not tied to coding, correct? Your identity. I mean, you're probably a quite genius coder, from what I take, but I think your identity is tied around building. So I guess I don't feel like you feel so much that you can still build stuff, correct?
Yeah, I actually, it's interesting. I actually think this is something that really benefited me because early on in my career, like I loved, there's kind of an art to code, and it's easy to get too caught up in that and lose track of, why are we even building this thing? What are we trying to solve? What is the problem to solve? And startups are a really good way to like kind of get that humbled out of you, because in a sense, like no one cares what programming language your application's written in. They might care about the performance. They might care about some of the things that affect them, which may be tied to the technical choices. But in the end, they care about the experience and the problems that it solves. No one really cares about how beautiful your code is, except if it enables you to ship more and maybe ship higher quality products that don't fail. So you kind of start to quickly get into the essence of like what actually matters, and it's not go write a ton of AI slop. It's also not go make sure every single, it depends on the use case, it depends on what you're working on. Like Redis has a very different bar from like a lot of the other products that we work on. But yeah, I don't think it's changed. Actually, it's been really enabling for me. It's enabled me to like do so much more, and anything I can think of, I can really quickly turn it into
Yes, like
something
from
real.
intention to code, like within minutes sometimes, or 1 hour, you can pull something off that is actually would
Yeah.
have taken you quite a long time. And you can validate ideas very fast through that.
If you look at how these things work, like if you look at the coding agent and break it down, what it's doing is you ask it to do something, it goes and its context is really your prompt in the code base, and it will go by itself and kind of look for your code base and figure out what it needs to learn or see. Like, oh, this function references this library, let me go read this library. It will go and use and find the context it needs to solve problems. And this is completely different from how a RAG system works, right? Where a RAG system is linear. With a RAG system, you are pretty much like, I'm going to go get you the context you need up front, and then you use that context and answer or do this thing or answer this question. I think the big thing that's changed and going to like kind of where context is going, what I've learned is the agent is actually best at deciding what context it needs. And so our job is building an architecture, which I would call a context engine, which enables the agent to navigate to find what it needs, be able to retrieve it quickly, make sure the data is always up to date. And in my opinion, the fourth pillar is making sure the data improves with time. It's like, as if context is all that matters, you want your context to be to continue to improve as you use it. In fact, as the agent's working with your code base, for example, it should be learning about how your code base works. It should be learning from your feedback, like how you like to write code, how you like to architect code, how you like your tests. And that's just all context. There's intrinsic and extrinsic or external, rather, context that's important.
I'm wondering, maybe we can also unpack a bit, also for everyone listening, because not everyone is so deep into these topics and want to learn. So we have the feature store now, and that feature store, it's more than a feature store. What you built, I would say it's kind of, like we said, DBT core for features, or for data pipelines for ML. And so and now basically people started to use that also for LLMs and agentic applications, correct? So the same stack as you have been, that you created before as a founder, is still very relevant, or even more relevant for the kind of the new world that moved from kind of classical ML models to agentic and LLM applications. Is that a fair statement? And maybe you can give some context to that.
Yeah, so the way it worked was we had Featureform. When LLMs came out, I was playing with them from day one. When MCP came out specifically, I was super interested in MCP because I saw it as a way to enable, for me, from day one, it was very clear that this was going to be the way that people access data with agents and LLMs. And I just found that the way people were building these MCP servers was really awkward, because it seems to imply tools. Tools imply like actions, but actually most tools are actually about retrieving information. And so the architecture for building that looked different. So originally the product was actually a completely separate product. We called it Enrich MCP at the time. It became what is now Context Retriever, which is part of Redis Iris. But it was a way, it's almost like an ORM for agents. You could like define data schemas. We use Pydantic. You define these data schemas and you allow the data, the agent to be able to access that data. So actually it kind of had nothing to do with the feature store. But what we found in practice was people would have it hit all these different sources of truth. They'd hit the CRM, they'd hit the some Postgres DB, they would hit all these different things.
Yeah. So connections. And MCP is basically the layer how you talk to these systems. Or basically it's the APIs wrapped with MCP, so the LLM or the agents can choose better what to use, correct?
Kind of, but the things that were different is, one, if you naively wrap all your APIs, you'll end up with way too many APIs. The agent won't be able to understand it and won't be able to be effective. In the same way that if I give you our API, like our Swagger docs, our open API docs, and I said, hey, here's our open API docs, can you put up a Redis DB with private link. Like it would take you a long time to just figure out what you're looking at and how to parse it. But if I gave you primitives like here's a DB, here's this, or the customer support case is much clearer to understand. It's like if I give you my Postgres DB or Snowflake DB and I give you a run SQL tool, it's not that useful. There's just so much time that would be required to even figure out what I'm looking at. But if I give you, hey, I have users, orders, items, whatever, almost like a semantic model, and I let the agent interact with a semantic model instead, it's going to be much more effective. Now,
I never thought this way. You're right. I mean, it's probably obvious, but like, I realized that I intuitively have been, of course, using MCPs like that. But it's so much more powerful than just giving access to the tool. What it does is basically describes, hey, you can find customers here. You can modify customer records there.
And if you start from the data model first, so what we do is you define the data model and we actually kind of compile the tools from the data model. And we found that we can really optimize things and make it much more effective than what most people kind of handcraft. Plus, it's just much more maintainable because it's a little easier to like wrap your head around. It's the same reason ORMs exist. Because
probably around 50% of the work you do is simply reading data, and maybe even more. Then you have maybe like 20, 30% of writing back data. Maybe it's even less. Maybe it's
I think it's 20%. Less. I think it's like probably like 90-10. Like I think 90% of tools are just retrieving information.
And I guess you have then 5 to 10%, maybe 5% or less of real actions where you trigger, write an email or do this or that, which goes beyond writing back data, correct? That's kind of like how LLMs are used. And so funny enough is that MCP servers have been mostly designed around that kind of later part, the less than 5% of kind of, I would say, true actions. I mean, reading and writing data is also an action, but it's a very specific data task, let me put it this way, compared to triggering an email or something else in a system.
And yes, exactly right. Now, if you take that step further, so now we have this idea, which is like we have a semantic model where you define your users, your items, and you let the agent interact with that. Now, the fact that it happens to compile to MCP, it could compile to a CLI, it could compile to whatever. It doesn't matter. That's implementation detail. It's like the programming language. The only thing that matters is the way you define the data model. That is the thing that is unique, and that's the thing that is important.
And that needs to be readable and understandable, correct?
Yes, by both humans and agents. Like it should be something where a human could look at it and kind of be like, cool, I understand what this is.
And what's the best strategy to do that from your perspective? Like in terms of how would you set it up so you have the data model described?
So the way I
so
we do Pydantic, Python oriented. This is maybe just a me thing. Like Featureform also, even though we could do YAML, it's all Python. I just don't want to add more YAML to the world. But even though it is declarative, it's just like I just like define. So anyway, the point is like there's this declarative way of defining this model, and there's two parts to the how. There's like the literal how. What's the API look like? In my opinion, you should just go install the Redis development agent skill, and just have that figure out the API for you. And the part that's important is thinking of how to actually model this data. And the way I do it when I work with customers is I have them describe to me. I'm like, I don't know anything about your company. Like, tell me how your company works. And it's like, oh, well, we have users who come and they do whatever, they buy things or they go to storefronts to look for food that they want delivered. And as they start saying, I'm like, oh, so you have users, you have this, what are the attributes you care about? And just if you describe it like you would to a person, you will naturally map to a data model that makes sense, again, both to a person and to a agent. Semantic models aren't new. Like we've been talking about them since pre-LLMs. The thing that's changed, especially from Redis's perspective,
since the 2000s, I remember, when I started my university in 2004 in Karlsruhe, actually we had a big semantic web movement back then going on.
Oh yeah, yeah. There's a lot of interesting companies that came out
Yeah,
back
Tim
then.
Berners-Lee, I think, started it or was one of the guys
Yeah, yeah. It's funny how much
with
like that
RDF
sort of.
emerging and so on, ontologies.
It's like it's yeah. We love it's there's a core kernel. There's like these sets of problems that we've never been able to solve, and I think ontologies is one of them. And I think we're trying to solve them all over again. But if you think about why these semantic models exist, it's to enable humans don't I don't know why I'm skipping on the word, but the idea is that humans, when they go and interact with data, they just figure things out. Like, you can't guess what query they're going to do. It's not hard coded. They're going to go and they're going to interact with the data. They need some sort of semantic layer. Now, pre-LLMs, we never had the idea of a semantic layer on top of Redis. If I told you I was going to build a semantic layer for Redis, you'd think I was insane because that doesn't make any sense. Like, the application code is the semantic layer. But now we have agents that are interacting with data and inside of Redis, and agents are non-deterministic. That's the word that took me a minute. Like, humans are non-deterministic. That's why we had semantic models on analytics. But now agents are non-deterministic, so we need semantic models on OLTP style databases that historically we would not focus on building semantic models on.
Which collapses the two worlds a bit.
It does. And in fact, if you think of like the other place where the two worlds collapsed, it was feature stores. And what you end up with is this architecture where you have...
Yeah, go ahead. But I was just thinking, like, this is exactly what DBT core, kind of DBT solved on the analytics side.
It is, but what you need is you need to mix that with data that is kind of real time. Because for
that
customers...
is missing,
And so what you end up with is, okay, I have this data, it's in my data lake or wherever. I need to use in our case, it could be Featureform. We have another product called RDI, which is like our kind of ETL product. You can build a materialized view of context, which maps to that semantic model that you're looking for. So then what you end up with is the agent can go to data in one place. You can control the data that exists for security purposes. You can avoid an agent accidentally taking out one of your production DBs. So Redis is like a very natural place. People do this with or without Iris. So you end up with this data in Redis, and then you put this kind of semantic layer on top, and it becomes the data. I almost think of it as like the data or the context delivery layer. It is the way to get context in the staging area set up for consumption by an agent. And where Redis is really good at this is, a lot of people think of Redis for speed. That makes sense. But the other thing Redis is really good at is the data structures. We have very unique data structures. We have like geoindices, we have vector search, we have hybrid search, we have just hashes, lists, time series. These things all map super well to how humans think, and that's why humans like Redis, and it also happens to map really well to how agents think. And so agents really interact well with Redis.
And so what has changed, like when you look at Featureform, having agents now as consumers, what has changed? Because before you have the ML guys, being the consumers kind of.
Yeah. I mean, the big thing that's changed is the architecture is a bit different. I think the things that have changed is almost everything in a weird way. The things that have changed are, one, the way we do work has fundamentally changed. We work through agents, and the agent interface becomes really critical. How do we allow our agents to interact with things, and how do we, is really critical. The other piece of it is a lot of the applications we're building. There's a lot of ML applications that still uses feature source in common ways. For agentic applications, with the new models, the only bottleneck of these new models is context. These models are able to reason so well; they can go for hours straight and solve problems. The joke I've told, around this is, if you put me in a room for 2 hours with a prompt, and you tell me to think about it, I'm gonna hallucinate for sure. After 2 hours, like you put me in a white room, it's exactly what's gonna happen. But if you give me a laptop, you give me access to context, access to all the tools that I need to get information to keep thinking and solve the problem, and yeah, I could go for much more than 2 hours and solve complex problems. And so the thing that's changed is that the agents they're here. It's happening now, and we need to find ways to feed them context. And all these data systems that we built, originally they were built for analytics use cases, then we had to kind of build this feature store idea to make them usable for ML use cases, and now we need to build them for context use cases. In fact, I think there's the DJ Patil article from way back where he defined a data scientist. He kind of said this is a job that needs to exist called the data scientist. And I think now we're going to see the rise of the context engineer, which looks kind of like a data engineer, kind of like a data analyst, but fully oriented and optimized towards building and getting the right context to agents at the right time.
Makes a lot of sense. What was the third thing? You said 3 things, correct?
Yeah.
So the way we do work, it's the bottleneck for models.
Yeah,
that is resolved.
I think it's the. I think there's 2 parts. There's the way we do work, and then the way we build smart applications.
Right.
So the way we do work has changed, and then the way we build these applications is so much about building context engines and using things like Iris to do so.
So one thought that I had recently, I was thinking a lot about context layer, and I was thinking, does it make sense to have context agents that interact with the agents? Almost like I was thinking of librarians, because we're building right now a bit of a small context layer for ourselves here at Data Masterclass, because we have 3 years of teaching materials and videos and everything, and tons of hours of coaching, and all of that is context for us that is very valuable. And so I was thinking probably the next agents I want to build is kind of librarians that help us, both software and agents navigate that.
It's so funny that you've said this and you use the term librarian, because I swear to God, I'll say it here first. We're gonna release something called the Iris Librarian.
No way.
I have a prototype of it.
No way. We did not speak about that. I swear to God, I did not know about it.
Yeah, and it speaks so right now I mentioned we have this data schema and it speaks MCP. We also have our memory service, REST agent memory. And one thing I've been thinking about is how do we unify this more? And the most obvious way is that you just make them, tools that kind of map and kind of. But the more I thought about it, the more I thought it makes actually a lot more sense to put an agent in between and make the interface A to A, because I can make my agent I can kind of KV cache all the tools. I can KV cache a prompt that's optimized for retrieval. In the same way, if I ask one of my engineering managers, hey, what's the status of X? And they send me the Jira board. And I have to go and look into all the epics and all the stories and try to fit it together. I'm gonna I'll probably forget what I was even doing by the time I figure it out. But if I ask someone, hey, can you do this? And can you put this together and compile it essentially into a response for the thing that I need? It's how humans work. It's how organizations work. So it tracks that agents will work the same way. So yeah, we are. This is very much something. I don't know when this is going to get launched, but either it will have already been launched by the time this podcast goes out, or it will just about to be.
Amazing. And so because it's so obvious. Look, the reason why there are librarians is because you come into a library, you don't live in that library. The librarian lives in that library. So they know the context. They understand which books are out there, what to recommend. They speak to people about books every day. And so it makes a lot of sense to have somebody like that. Or, somebody working in a pharmacy. Not everyone is a pharmacist. And so it's kind of obvious, and I was thinking I haven't seen that so much out there yet. So I'm very excited actually, and I would love to see actually what you guys have built.
I'll give you one of the first external sneak peeks of it, but yeah, it works really well. Obviously it adds a little bit of latency. What's interesting, which it makes sense, but I didn't expect it, is it actually saves a lot of token costs too. because you're kind
because
of
the
creating.
context window becomes small.
It does,
Leaner.
but you're splitting it into two problems. So I was thinking that, oh well, the librarian, like I'm moving the token cost to the librarian, but actually the
No.
token cost across both of them combined tends to be less than if you just have one
Yeah.
agent go do it.
Which is completely logical. I mean, because you specialize.
Exactly, and then it actually really opened. We see a lot of multi-agent systems, and I actually think of multi-agent systems as pretty much. I think of it as like almost like a stack, like a where it's like, oh, I want to push a new stack frame so that I have no none of this information from down here except for the things that get passed in, and I want this stack to go and solve this problem. And then return the response. It's in a weird way, it makes multi-agent systems. You think of multi-agent systems as like if you take a context window or a conversation, it makes a lot more sense to take the task to solve and break it into subtasks and have each agent context window really like focus on subtasks and then merge them back into the final thing that puts it together. So I think we'll start seeing it this year. I've definitely seen a million multi-agent systems, but I think today a lot of people do them, but I think the value creation will come soon. So a lot of what we're thinking about right now is about context. I think that's the number one problem to solve, but I actually think the next problem is going to be all about multi-agent.
I think that the biggest limiting factor why multi-agent systems in bigger companies have not taken off is because the context is not there, not well managed. And so I think we need to start with the librarians.
Exactly. I think that's what's going to happen. I think what we'll see is like first it'll just be MCP tool-based context retrieval. We're seeing that agent memory, things like that are critical. These are all things we built into Iris. But then the next piece of it that will come after is I think people will get more comfortable with multi-agent systems. We'll know how to really optimize a single agent. And it's not that multi-agent systems are inherently... I think the best way to think of it is really just that. Like, hey, I want to kind of create like a VM to solve this problem and then return back. I don't want to kind of put all of this stuff in the agent's head, have to kind of do the math itself. So I think the more we think that way, the more we'll build these new types of systems. It also maps really well to microservices. MCP does too, but I actually think a lot of teams are already trying to kind of
Make it
so exactly like each team has its own agent that you can go talk to get what you need from it.
That's exactly. By the way, we last week we actually had Data Masterclass Europe, which is our flagship event once a year. And we actually announced one of the biggest kind of pivots that we see is that we see the return of the mesh, the data mesh, but looking also at agents. So basically, domain teams would also own their agents and their software. Because like in many large corporates, they don't have software teams inside teams right now. Like in tech companies, like we know you have tech teams everywhere. But in traditional most companies, they don't. And vibe coding gives you the ability to, and vibe engineering gives you the ability to actually do that. To have software and agents, so basically self-service AI, self-service analytics, self-service software owned by these domain teams, which I find super fascinating. And one thing that we actually discussed as part of it, and I would love to hear your take on it, is what happens with knowledge? Because like a key part of solving the context problem is understanding the workflows and understanding tested business knowledge. And so one thing that we've been starting to do with our members is to look at how can we capture that domain by domain. So we capture the most important workflows and then also the tested knowledge. And by the way, the most effective way we found so far is simply talking to your phone. Let's say you're an expert of a piece of machinery, operating that machinery. If you just talk to your phone about that and you just say, hey, I'm doing this is what is important and so on. You just talk as you would talk to your friend. This gives you the most valuable context. Because usually if you like the normal thing that you find in a business is you have step 1, step 2, step 3, step 4, step 5, but then the expert comes in, weeks later and says, oh, what you have not figured out is that's that customer, you have to do that because it's different.
I think that one of the most untapped parts of agents is, and all these AI tools, is actually voice. I think the coolest thing is we're so used to working in. I like to put it this way. If you look at like a screenshot of like Windows 95, it looks like ancient now. It's so funny to imagine that there was a day where that looked really modern. That was like
I remember that day very well. Yes.
And I think we're gonna look at SaaS applications, and it's gonna look really similar. Where we're gonna be like, a SaaS application in many ways is just like humans manually entering forms into a database. It's just like a wrapper over a database, and it's like we used to do that. It's actions. Like, of course. But there'll be this feeling of like we used to do that manually, and I think that's what we're gonna look back on. I think in practice, like it's much more natural to interact with voice and with text. And so I don't know if you haven't tried it, if you're listening to this and you haven't tried it, I love actually writing code with voice. Where I'll read, I'll be talking out loud, and my wife thinks I'm insane, but that's I felt like I have that little Bluetooth headphone where you're walking down the street and people think you're crazy. It's kind of similar. It's like, what are you doing? I'm like, well, I'm talking to my agent. I'm writing code. But it works really well. And I actually think this is, I think it is a really good way to capture knowledge, is just let people speak and let the agent figure out. Because otherwise what you have to do is sit, organize all your thoughts, collect everything, which you can do, but also LLMs are really good at that.
But at the end, kind of, you can translate that into Markdown files and put those Markdown files somewhere. Would that place be, again, in your architecture Redis? And you still do the declarations in Featureform?
So in this definition, so we do it in a few different ways. Like there are these different data structures we have. Like we have our vector search. So you could have as like embedding based vector search. You could do it just be a BM25. It could be a GeoIndex. It could be time series. So you have a lot of data structures you can map into. We also do have a file system, Res file system. We have the little, it's part of our AI lab. It's a Redis file system product where you can actually put markdown files directly. I think it's more of a implementation detail. I think the main idea is actually defining what context do we need and how does the agent need to consume it, and then that will naturally map to what it is. Markdown files work really well. In fact, I think if you try to make every problem look like a coding problem, you're going to get really good results, because that's what agents are really good at. So I think about that a lot. Like, how do I make this look like a coding problem?
I love that. And so I'm also thinking, like, if you have a librarian for everything that is in your library, maybe there's also a knowledge, agent that interacts with these, markdown files that come from humans, and it's like a diplomat, like a translator, between human and machine, and learns how to best translate that to something that is useful.
One thing we do in our memory product, I call it like dreaming, where it's actually like over time it is merging thoughts, or merging rather memories, it's deleting memories. And so you also end up with this kind of, you need it to be able to do that stuff. The only problem, like the one maybe hot take I have, or one of the hot takes I have, is that I think everyone wants to try to do this stuff with knowledge graphs. And I don't think it works. I think it could work, but I don't think the technology where it is enables knowledge graphs to work. I think it's much easier to work with like markdown files, tables of content, text of like kind of directories tends to work a lot better. Trying to make a proper, because to build a really good knowledge graph, you need to have an overarching knowledge of the whole system to really perfectly put it together, or you're just gonna end up with a ton of repeat nodes, repeat edges. It's really hard to do for anyone, even a human. So like, I think we want it to work so badly because it feels so logical, but I don't think it works.
What do you think prevents it from working? Is it something? Yeah.
In the same way, if I told you, hey, let's take everything we talked about today and turn it into like a graph of things, it would take a while to like even figure out, well, does that count as this node, or is there an edge here, or does it connect here? And it's really hard to get it right. And
I have a gut feel about this. Because I've spent a lot of time on semantic graphs and so on. And my gut feel is we're missing some dimensions there. We're trying to put it into a 2D structure and it doesn't fit.
But if you think of like a n-dimensional structure, it starts to look like an embedding space.
And you said in the beginning, I remember, embeddings felt to me like magic.
Yeah, I think it, and in fact, one thing we used to do is we would create these things we used to call user personas, where we would cluster user embeddings, and we would then take very normal like kind of analytical dashboards, but we would do it per persona. So we'd use the personas to split, but the personas would be completely generated via the clustering of the embeddings, and it worked super well. So it makes sense that in a sense what an embedding is you're forcing the the model to look at all the data at once and try to figure out, how do we put these things together to capture all the nuanced semantic similarities and differences between everything else.
So in a way, it kind of takes the world, which is super complex, and tries to bring it down to an essence that is usable.
Yeah,
and every time you do that, customize based on the knowledge, you kind of customize what's the best representation of that knowledge.
And the reason we hate it is that we can't look at an
it.
embedding space and easily understand it the way you can a knowledge graph. So we want a knowledge graph so badly. We want to be 2D so badly, but I just don't think it's. I think it just requires, like, even when humans do it, they make a lot of decisions, they take a lot of shortcuts because it's impossible to do it perfectly. But when LLMs do it, it just ends up quite bad very quickly.
Yeah, and funny thing is that I think embeddings are much closer to our brain structure, how it's organized than knowledge graphs. Anyway, so maybe last topic to discuss today is let's talk about sovereignty, because that's something top of mind right now for a lot of people around the world. Everyone knows Fable. Everyone knows that it was switched off, and so the question comes like, as a company, do I want to feed data to the big AI companies? If I have like really valuable 400 years old knowledge around the engineering problem, electrical, physical, manufacturing engineering problem, do I want to put that and upload all of that? What's your take?
Yeah, I think we've talked about data being a moat for a while. It's not a new term. But I think as the models get more and more powerful, and with LLMs especially, it is becoming especially true. In fact, we saw Cursor built, they fine-tuned their model based on, I think it was Kimi, and moved off of whatever they were using, I think a mix of Anthropic and OpenAI before. The reason they were able to do that is they were able to collect, I assume, I was there, but my assumption is that they were collecting all this RL data, how our agents interacting with code bases, what's good, what's bad, and they're able to use that to fine tune an open source model to achieve similar results as the cutting edge models. What I tell startups that are building especially, but I think it's true for most teams, is if you use like an Anthropic model or an OpenAI model, that is pretty much the peak of what is possible to do right now. So it's a good way to prototype and to make sure that what you have is actually feasible. Yeah. And if it is, I think the next step for a lot of companies is okay, well, how do we own this thing ourselves? And how can we use lots of the open source models and get it to achieve similar values? But yeah, I think it's a very multifaceted conversation. But the short of it is like, yeah, I mean, it's your moat. Like, you don't want to give away your moat.
Yeah.
But I also think it's understanding what data is actually is your moat, because I think a lot of people kind of overturn the other way, and they're like, I don't want to use any of these things because I'm afraid of them having this data and there's a sweet spot, and it's going to depend on the company.
There's a sweet spot, and you can also use these powerful models to build something and then put that into your kind of more protected environment. But I guess the big question is, is open source a solution for this? Because I mean, you've been part of the open source movement. You've been contributing quite a lot, I guess, over your life. There's a reason for that. What's your belief behind this?
Yeah, I'm a huge believer in open source. I think open source is especially for things like these models, it's such a natural place for open source when you have these huge problems that exist, that if you let everyone be able to work together on, you'll end up with a better result. And you'll end up with, especially for a technology as fundamentally like changing as AI. I know. I also think there's a part of me which is like, I want everyone to have access to this. It's such an unfair advantage. And I love that companies are making that possible. But yeah, wonderful. I think open source is a huge part of the solution here. And I'm a huge believer in open source and advocate of open source, and love to use and contribute to open source where I can.
Yeah, as you know, at Data Masterclass, we strongly believe in that open source is part of the solution to get more sovereignty, but also more empowerment of people, so everyone is really usable by everyone. We are preparing to launch an alliance around that on sovereign AI, sovereign agentic OS, we call it, and more to come. And I hope we will partner in this. Simba, it's been an absolute true pleasure to record this with you. I learned so much, really. I mean it from my heart. I learned so much from you in this hour. Thank you so much for your precious time.
It was super fun. Thanks for having me.
Data Masterclass, where great data journeys begin.